Introduction. Population growth rate is a fundamental concept in ecology that quantifies changes in the size of a population over time. Understanding population growth rates is essential for studying the dynamics of biological populations and assessing their impact on ecosystems. In this guide, we'll explore the methods for calculating population growth rates in ecology and discuss their significance in ecological research and conservation efforts. Calculating population growth rates. Exponential growth model. The exponential growth model describes population growth in an idealized, unlimited environment, where individuals have access to abundant resources and face no limiting factors. The formula for calculating population growth rate, R, using the exponential growth model is R equals ln n0 t, where R is the intrinsic rate of natural increase. Nt is the final population size at time t. N0 is the initial population size at time 0. T is the time interval in years. Logistic growth model. The logistic growth model incorporates carrying capacity, K, the maximum population size that an environment can sustain indefinitely, into the equation. The formula for calculating population growth rate, R, using the logistic growth model is R equals K nt, K asterisk nt, where R is the intrinsic rate of natural increase, K is the carrying capacity, nt is the population size at time t. Interpreting population growth rates. Positive growth rate, R greater than O. A positive growth rate indicates that a population is increasing in size over time. This may occur in populations experiencing favorable environmental conditions, abundant resources, low levels of competition, or high reproductive rates. Negative growth rate, R and LT, 0. A negative growth rate indicates that a population is decreasing in size over time. This may occur in populations facing adverse environmental conditions, habitat loss, resource depletion, predation, disease, or human impacts. Zero growth rate, R equals O. A zero growth rate indicates that a population is stable and maintaining a constant size over time. This may occur when a population reaches its carrying capacity and experiences density-dependent regulation, balancing birth and death rates. Applications of population growth rates. Conservation biology. Population growth rates are used to assess the status of endangered or threatened species and inform conservation strategies. Monitoring changes in population size, reproductive rates, and habitat quality helps identify species at risk and prioritize conservation efforts. Pest management. Population growth rates are used to study the dynamics of pest species, such as insects or invasive species, and develop effective management strategies. Understanding factors influencing population growth helps predict outbreaks, implement control measures, and minimize impacts on agriculture, forestry, and ecosystems. Human population dynamics. Population growth rates are used to study human population trends, demographic patterns, and resource consumption. Assessing population growth rates helps address challenges related to overpopulation, urbanization, food security, and sustainable development. Conclusion. Population growth rates are fundamental metrics in ecology that provide valuable insights into the dynamics of biological populations and their interactions with the environment. By calculating and interpreting population growth rates, ecologists can assess the health of populations, predict future trends, and inform conservation, management, and policy decisions. So next time you encounter population data in ecological research or conservation efforts, remember the significance of population growth rates in understanding the intricate web of life on our planet.